Oh, sorry, YouTube. I did not have the microphone on. You're probably wondering what the heck I'm doing. It's on now. You were correct. Yeah, not very many people watch videos anyway. It's okay. Let me change it. Not very many people outside this class watch videos, so not really concerned. On some of them, some. I have been to Georgia. I've been to Atlanta. It was very warm. I was there in July. Hot Atlanta. Thank you. I appreciate your confidence in my profession. You make me feel like I'm doing a good job. That's okay. I understand what you're saying. I'm not good enough to be a teacher anymore. All right. So what about the trapezoidal sum? The trapezoidal sum is a little bit confusing. We can only investigate a little bit of it today and not the entire piece. But I'm going to show you, and really here's the basis of the trapezoidal sum. Part of the question is, are the bases of the rectangles the same? And when we look at really I guess the pure aspect of calculus and where it came from, everybody would say, well, of course you always make the triangle so the bases are the same. The AP world has said, well, we're going to throw a couple problems here or there where that's not the case. And AP is very cultish in that. There's certain aspects that AP uses that the truth is you'll never see them again in your life. Like you'll get a full math degree and you will never see any of the AP pieces that get talked about. And I hate to say it, but it is the truth. So we're going to look at rectangles that don't have the same base in a little bit. But right now we're going to keep the bases the same. And for the trapezoidal sum, this is a little bit different. I want you to understand. I'm going to do the right hand in blue. And I'm going to do the left hand in red. And I'm going to do the trapezoid in green. I'll pause for the green one here in a second. You guys can. The trapezoid looks like this. I'll do it again. So the trapezoid looks like that. You see how I have two green trapezoids in there? And those look like really good estimations, don't they? Can you see by the work that I have there that the trapezoid is simply the average of the right hand and the left hand? So the cool thing about trapezoid sum is this, is that it's a really good estimation if the bases are the same. If the bases are not the same, then it's a little bit more complicated to actually calculate. It's still a really good estimation, but in this situation, the midpoint, or I'm sorry, the trapezoidal sum of 2 is simply equal to the right hand of 2 plus the left hand of 2 divided by 2. It's just the average of them. That's all it is. Okay? So we'll consider some shapes coming up here where the trapezoid is where we don't have the same base all the time. But for this purpose, let's start by looking at a table. It says use the following table to determine the appropriate area bounded beneath the function over the interval -2 to 6. So classic AP question right here, super easy. I would expect every person to get this right on the test. Okay. Go from -2 to 6. So what's the width of the entire interval? Yeah, I've got 8 for the entire width. And I want how many rectangles? I want 4. So what's going to be the width of each rectangle? So the width of each rectangle is 2. And so I'm going to just draw these kind of lines here to show, my intervals for the rectangles. And remember yesterday we said that you could just take the width times the sum of the heights, right? Instead of taking the width times the height and the width times the height and the width times the height, we just take the width times the sum of all the heights. As long as the width is the same. Is the width the same the entire time? It sure is. We just take the width times the sum of the heights. So I want to do the right hand. So where do I evaluate the first height? 0. And I evaluate the next height at, and I get 7. Evaluate the next height at, and I get 8. And the next height at, and I get 6. So we've got 2 times 8 plus 8 is 16, plus 6 is 22. I get a total of 44. Watch what happens with the left hand. With the left hand, we have 2 times, where do we evaluate our first height? You evaluate -2, so you pick up 5, don't you? But then aren't the rest of the values the same? Yeah, you got 1, you've got 7, and you've got 8, but you leave off the 6. So the right hand and the left hand really aren't that much different except for the first term and the last term. Got that? So I have 2 times, let's see, 6 plus 15 is 21, and I get 42. Any question there? Midpoint, where do you think I evaluate the height for the first interval? Yeah, in between -2 and 0, so I evaluate at -1. So the first height is 10. What's the second height? 5, then 16, then 5. And what I get is 2 times 10 plus 5 is 15, plus 21 is 36, so I get 72. Is that right? And as long as the widths are the same, then the trapezoidal sum, you can simply just do the average of the right hand and the left hand. So T sub 4 is equal to R sub 4, which is 44, plus 42, divided by 2. 43. Only if they're the same width. What's that? We all good? Okay, flip it. What do you notice about the intervals here? They're not the same width, are they? They're not the same width at all, okay? So what I want you to do, let's see if I did this right. 1, 2, I've got 5, don't I? So I didn't, let's see, what should we do here? We'll do, so I changed this problem. This is a new problem for me this year, and I forgot to change these parts. We're going to go R sub 5, L sub 5, T sub 5, and we're going to go 0 to 16. So I want to find the area from 0 to 16, and I want to do 5 rectangles. Are we able to divide these up into equal widths? No, we're not. You see that you have a width here of 3, a width here of 1, a width here of 3, a width here of 4, and a width here of 5. So in that scenario, we can't use the same width. That makes it a lot more complex. But you guys are really smart. And because you're really smart, we're going to be able to do it. R sub 5. I have this region right here, then this one, then this one, then this one, then this one. What's the width of the first rectangle? 3 times, what's the first height? It is 3. I evaluate it on the right-hand side. Plus, what's the width of the second rectangle? 1 times plus 3 times 5 plus 4 times 4 plus 5 times 2. So I get 9 plus 6 plus 15 plus 16 plus 10. Very common on an AP exam that they give you this type of problem and say no calculator. Okay, you need to do this computation by hand. Question. Yeah, so this is my first interval for my first rectangle, right? So I want to do the right-hand side. So the first height is 3. The width is also 3. 0 to 3. For the second rectangle, the width is 1. I evaluate the height here, 6. Width is 3. Height is 5. Width is 4. Height is 4. Width is 5. Height is 2. Better? Okay. I add all that up, and I get 15 plus 15 is 30, 40, 56. So what we got? You try L sub 5 on your own. Go. Okay, then what about the trapezoidal piece? This is where it gets just a little bit more goofy. And so first time I've taught through this problem, so I really need your help, folks, that we would understand this well together, okay? So I'm gonna try one explanation. If it doesn't work, then we can start again. Okay, so if I were to take this shape right here, notice how it would have a width of 3, right? It would have a height of 1, and then it would have a height of 3. And I would connect that together, it would make a trapezoid. Do you see that? So we have to consider the area of that trapezoid. What's the formula for the area of a trapezoid? Yep, good. Lots of different versions of the formula. That's the one I go with. Okay, so as you look at the trapezoid, and we know that this dimension here is 1, and we know that this dimension here is 3. Okay, can you tell me I have 1/2 times, what's the height in this problem? It's 3. Which 3 is it? The one on the side or the one on the bottom? The one on the bottom is the height. Do you see that? It's a trapezoid sitting on its on one of its sides. Do you see that? What are the bases? 1 and 3. You see that? So that's the tricky part about this problem is when you get on the AP exam, you know, people immediately when they go for the height ends up being this width. You see that? I'll do it again for the next one, and we'll hopefully even understand it better. But so I have 1/2 times 3 times the sum of the bases, which is 1 plus 3 or 4. Now I'm going to write all of these out for each one, and then we'll compute it together. So I'm going to draw another rectangle. I'm sorry, another trapezoid. What is this dimension right here? 3. What's this dimension here? 6. What's this dimension here? 1. So what's the height? 1. What are the bases? 3 and 6. Do you see that? Okay. So I have 1/2 times 1 times 3 plus 6. If I picture me flipping this on its side. 3, 6, 1. Height is 1. Bases are 3 and 6. That's really what we're doing. Okay, now I think we probably have a little bit of understanding what this looks like. So the next one is going to be 1/2 times, what's the height of this one? 3. What are the bases? 6 and 5. And then I have 1/2 times, what's the height here? 4. And what are the bases? 5 and 4. What is the height here? 5 and the bases? So remembering that the width of the interval is really the height of the trapezoid, that's key. So we can multiply these all out and add them together. I get 4 times 1/2 is 2 times 3 is 6. And on the AP exam, they love to see your work written out like this because you get partial points along the way, okay? So this would be this would be in context of a 9-point problem, and so you get some points for doing some of this work. Not all this work would be worth 9 points, but this would be worth 2 or 3 points for you. 3 plus 6 is 9 times 1/2 is 4.5. We going with, okay? And then we got 11 times 3 is 33. 33 divided by 2 is 16.5. I like even numbers. 1/2 times 4 is 2, and then 2 times 9 is 18. And then 6 times 1/2 is 3 times 5 is 15. And I don't know how many times I've done a practice AP problem and I've gotten the problem wrong because I simply just did not add them up right. Because again, this would be a non-calculator problem. Okay. And so I've got, let's say I'm going 21 there, and I'm going 33 there. So 21 and 33 makes 54, plus 6 is, I've got 60. Can somebody confirm that? Okay, yay. Oh, thank goodness. If you notice, this came out to be 64, right? If you average these, oh, do you come out with 60? You know what? It would probably work, but here, so you're wondering, so part of your wondering is this: is why not just do that all the time? On the AP exam, they won't say do the right hand and the left hand. They'll say just do the trapezoidal. And so you would either have to do the right hand and the left hand and then divide them by 2, or do the trapezoidal like that. I would have to do some thinking to say, is it going to work out that way every time to where it is the average? I don't know. It would seem that way. And the reason why I'm hesitant to say is I remember going through a problem like this at the AP Institute, and the instructor told me, said, because I started doing the left hand and the right hand, I was just going to average them, and the instructor said, do the trapezoidal one. And I can't remember if she said that because that's how I would get points on the test, or if it was because that was the only way to come up with the right answer. Because it seems to me like you should be able to just average them still. Maybe she was cautioning me for it taking more time. But I remember her saying that. She said, just do the formula, Kevin. I'm like, okay. she called me Kevin. Yeah, so. All right, good. Are you ready for an easier problem? Okay. Approximate the area bounded between the curve f of x equals negative x squared plus 16, the x-axis, and the y-axis in quadrant 1. So part of what you'll be expected to do on the AP exam, and also my class, is first come up with a picture. What does negative x squared plus 16 look like? Or 16 minus x squared. And I want to find the area, it says, in the first quadrant. I want to find this area here. Anybody know what this spot is? It's 4. How do you know that? Yeah, you solved, that's where it's equal to 0. How many rectangles? 5 rectangles. So if it's if the entire interval is a width of 4 and there's 5 rectangles, what's the width of each rectangle? 0.8. So I'm going to do 0.8, 1.6, 2.4, 3.2. I have the entire width of 4 divided by the number of rectangles, which was 5. Your width divided by the number of rectangles is going to tell you the width of each rectangle. So I have right hand, left hand, midpoint, and trapezoid. If I'm going to do the right hand, where do I evaluate the heights? What do I plug in for my first height? Right hand, 0.8. And where do I plug the 0.8 into? The function, right? Yeah, there it is. So I'll take out my calculator. Duelitzer said we should go to the table. Okay, we'll go to the table. I'll go 16 minus x squared. We're going to do whatever Alex wants to do today. And I plug in 0.8. So I have the width, which is 0.8 times the sum of the heights. What's the first height? 15.36 plus 13.44 plus 5 point, really? 7.74? 10.24. Okay, so I value 0.8, 1.6, 2.4. Now I got 3.2. If you plug in 3.2, what do you get? 5.76. That's 1, 2, 3, 4. I should have one more. Oh, why 0? Yeah. Is everybody okay with how we got those? So watch this now. So I mean, let's save some time here. Let's not even add it up, okay? Let's not even add it up. Okay. You want to add it up? Okay, go ahead. Add it up. Tell me what you got. 35.84. Great. So if I want to do the left hand, I'm going to show you how quickly I can do the left hand. We talked about this earlier. I've got 0.8 times. Where do we evaluate the first height? 0. So you pick up the 0, which will bring you to 16, right? And you're going to have all of these here, except you'll lose the last one. So plus 15.36, plus 13.44, plus 10.24, plus 5.76. So you're going to pick up the first one, but you're going to lose the last one. What'd you get? 51.84. Trapezoidal is going to be super easy, isn't it? For the trapezoidal sum, I just take 35.84 plus 51.84, and I divide it by 2. Can somebody calculate that for me? 43.84. We haven't talked about the midpoint yet. Midpoint. What spot do I evaluate the height for the first midpoint? At 0.4. So 0.4 is where you evaluate the height for the first midpoint one. Here's what everybody makes a mistake on. Not everybody, but a lot of people. If I do my first height at 0.4, and the next one, as Dylan says, 1.2, and the next one would be 2. Okay, what's the width of each one still? The width is still 0.8, right? Do you know what people generally put for the width? 0.4. The width is still 0.8. You have 0.4 on each side. So we still have 0.8 times, and we need to plug in 0.4, 1.2. We need to plug in 2. We're going to have to plug in 2.8, We're going to plug in 3.6. Somebody give me, we got 5 values we need to come up with. Katie, you got one? 15.84. Uh-oh. 48.64. Thank you. Okay, we all make mistakes. Okay, you plugged in 1.2. What do we got then after 15.84? What do you got? 14.56. 12 even? Yep, that would be right because we plug in 2. What do we get after that? 8.16. That's 4. I've got one more value then. 3.04. Good. So add those up and multiply by 0.8. What do we get? I'm guessing it should be between 35 and 48. It should be probably close to the 42. 42.88. Looks like it's about right. Should be close to the trapezoidal sum. Should be less than the left hand, more than the right hand. And if you wanted to come up with an exact value, we could do y equals and the 16 minus x squared, zoom 6. And does anybody remember from yesterday what we could press? Second, calculate which one? Number 7, lower limit 0, upper limit 4, and you get 42.6 repeating. So our trapezoidal sum is actually, it's pretty darn close. We did a really good job. You guys did a really good job. I just stood here and put stuff on the board. Good work. So here's the deal. We will do this example today. The worksheet that you're going to get today is the worksheet for today and for tomorrow. Tomorrow, all we have to do is finish off this guy right here, and that'll be it. We'll be all right. I don't want to go too quickly through this. We might lose something along the way. Hi there. Okay, last example for the day. It says, use the following graph to evaluate the sums over the interval 0 to 120. I have 0. I have 120. I'm going to find right hand of 4, left hand of 4, midpoint of 4, and trapezoidal of 4. You should also be able to do this using a graph. So we've done by looking at table values. We've done by looking at a function. And we now want to be able to look at the graph. So right hand of 4. What's going to be the width of each rectangle? 30. So I have 30 times, where do I evaluate the first height? At 30. And what is the first height? 40. What's the second height? 80. 20. Very good. It is a big number. Good job, buddy. 30 times, we've got 120 plus 120 is 240. 24 times 3 is 72, so I'm going to go with 7,200. That's what I'm going for. On the AP exam, this would be a no calculator problem. Okay. And by looking at this, what do you think? Overestimation or underestimation as a whole? I'm going to say over. You got 3 there over and 1 that's under. So we would expect that the left hand would hopefully be an underestimation then. And maybe the average of them, the trapezoid, will be really good. So let's do left hand. So where do I evaluate the first height? And you get 0. Yeah, look at that first height at 0. Yep. And then I've got 40. It just picks up the other values that we had, doesn't it? Yeah. So you can see how the calculus works. We have 40 and 20 is 60 plus 80 is 140. So 30 times 140, let's see, 3 times 14, I'm going to go 42. So 4,200 I'm going with. And I'm going to do the trapezoidal right away because I see here that what's the difference between these two? 3,000. So if I do half or 1,500, that will bring this to 5,700 if I average those. I could see that right away. Is 1,500. I add the 1,500 to 4,200 then, or subtract it from 7,200, and I'll get in the middle. Yeah. Or, yeah. We good now? Okay. All right. Now the midpoint, that's a little bit different. So let's be clear. When I do the midpoint, what does my width change to? It doesn't change. Very good. It's still 30. See how I tried to mislead you there? I am a tricky guy. All right. So, but where do I evaluate the first height? And what do you get? Look at that. Isn't that a nice overestimation and underestimation? It's a really good job, isn't it? Yeah. So I get 20 plus 60 plus I'm going 50. It's going. It's 15 on each side for the rectangle. So it's still a full width of 30. The true rectangle that I'm drawing looks like this. Just the spot in the middle is what I use to get the height. Better? And then I've got, what's the next one? 60. And this would be a no calculator problem on the AP exam. I've got 120, 140, 190. So I got 30 times 190. 3 times 19 is 57. That's what my second grade teacher taught me. And so we're going to go with 5,700. What do you notice? The midpoint and the trapezoidal are the same. And if you have a linear function, that will be the case. So, yes, D. Weiland. Hi. Definitely not. Oh, okay. No, no. You okay? Thank you. You raise a really good point. I want to be clear here because they will assess you this way on the AP exam. You have a line, don't you? Would you agree that that's 80? Would you agree that that is 20? What's halfway between 80 and 20? 50. And if you would have said 60, you would be wrong, and you will not get the points. Sorry. It's okay. So I get that you look at it and you said 55, but they will say that it's a line, so you can find the middle. You're going to argue with my second one? Okay, let's go. That's 40, that's 80, so this would be 60. All right, we'll pick up with the next piece tomorrow.